Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 298. Please turn to page 298. Page 298. And today is our lesson number 244. The very first problem that you see there, problem number 14, is something that I did on problem number 14a. I did it day before yesterday. Look for 242, day 242. I did it day before yesterday. And then part B, 14b, is something that I did on day number 243 yesterday. Today is 44. It's something that I did yesterday. And then problem number 15. Problem number 15, I did it a long time ago because this problem appeared in the old GRE, the first edition of the revised GRE, and I did it on day number 199. So that takes care of problem number 14 and 15. What I want to do today is problem number 16. What we want to do today is problem number 16. Let's take a look at it. In problem number 16 on page number 298, they give us a normal distribution. Let me reproduce here. So there's a quick notation here. The day 1 through 200, I solve all the problems from the first edition, and all of these problems appear in the second edition. Just look for the appropriate page number, you should be able to find it, because they have not changed the page numbers. Surprisingly enough, all the page numbers are exactly the same as the ones in first edition, which works out well for me. Anyway. So here's a normal distribution. Nothing extraordinary about it. So obviously if there were something extraordinary about it, then it will be an extraordinary normal distribution. It will be an oxymoron. It's just a normal distribution. And we know that within the first standard deviation, we captured 34% of the population on the right hand side of the mean, 34% of the population on the left hand side of the mean. Oh, before I forget it, so that takes care of problem number 14 and 15. Before I forget it, if you want to understand the concept of normal distribution in a lot more details, I spent an entire day on it. You should watch day number 36. Day number 36, because right now I'm going quite cursorily. I'm going to digress for a second. You're going to have to excuse me for about 15 seconds because I want to find out which day we covered this word. Just excuse me for 15 seconds. I'm going to run to the room and come back, okay? The word that I just put down on the blackboard is cursory. Do you know what it means? What does it mean to do something in a cursory manner? We're digressing here. We were in the middle of solving a math problem, and all of a sudden this is turning into a vocabulary problem. But it's always a good idea to improve one's vocabulary, because vocabulary is a very important ingredient of the English portion of the exam. Having a good vocabulary is a must. Day number 22, you see? Day number 22. Now if you do not know what I'm doing right now, in addition to the math video that you're watching right now to help you with the math part of the exam, as I said, vocabulary is a very important ingredient of the verbal part of the exam, and for that purpose I put together some vocabulary videos. Look for them on my channel. For example, this particular word, cursory, if you want to learn it in detail along with some other good words for the GRE, just type in vocabulary, day 22, and if it doesn't pop up, try it with my name, Keshwani, and then vocabulary day 22, and it will pop up right away. And the word is cursory. To do something in a cursory manner means to do something in a to do something in a haste. If you do something in a haste, if you do something in a hurry, you're doing it in a cursory manner. What I was saying is that right now I'm going to put together a normal distribution here, and I'm going to do it in a cursory manner because I've already done it in detail. If you want to understand what normal distribution is and what the hell they're talking about here in terms of percentages, to understand this part, watch this day. Just type in revised GRE math day 36, and you will understand the concept of normal distribution in a lot more detail. What will be the adverb of cursory? Cursory is the word. What will be the adverb? The adverb would be, because we have the flair for the dramatics, I need my red marker. The adverb would be cursorily. You have to say it slowly, otherwise you will muck it up. Muck it up with an M, not an F. Cursorily. So I'm going to do it right now quite cursorily. That is, put together the graph and a normal distribution and so forth. But like I said, if you want to learn about it in detail, if you're shaky on it, if you don't quite understand where these percentages are coming from, watch day 36 and you will learn it. Cursorily was the word. So we know that in a normal distribution we have 34% of the population to the left of it within one standard deviation. So this is your mean. This is the mean minus the one standard deviation right here, and this is the mean plus an standard deviation. If we go one more standard deviation, we capture other 14% of the population. We capture the other, right here in this part here, we capture the other 14% of the population, which is the mean plus 2 standard deviation, and this one would be the mean minus 2 standard deviation. In other words, let's keep it very simple. I'm gonna make it very simple for you here. Listen, 34 plus 34 is 68. The way I remember is that the first standard deviation around the mean, captures approximately 2/3 of all the observations. In other words, if somebody tells you that they went around the town and they measured the height of all the 10-year-old kids in the town, keep listening. I'm just making it up. So I went around the town in the city and I measured the height of all 10-year-old kids, and I'm telling you that the average height was 4 feet. And I'm also telling you that the standard deviation was 6 inches. I'm making it up, you understand? These are not realistic figures. So this is the mean. So if I tell you that I took the survey of so many hundreds of students, or so many hundreds of kids, or so many thousands of kids, and I measured the average of all the observation, the average turns out to be 4 feet, the standard deviation turns out to be 6 feet. If I tell you that part, what we know from here is that within the first standard deviation, this is the mean. This is the mean plus one minus. This is the mean minus, to the left of it, 1 minus 1 standard deviation. This is mean plus 1 standard deviation, which means 2/3 of all the kids in my survey. If I tell you that this distribution happens to be a normal distribution, which most of them are, this is how nature created the universe. Most phenomenon in the nature obey this normal distribution, just like height and some other features of human being. So since this is a normal distribution, it tells us that 2/3 of all the kids are going to be between, this is 4 feet, this is 6 inches, 4 feet minus 6 inches is 3.5 feet, 3.5 feet, and 4 feet plus 6 inches is 4.5 feet. So that tells us that 2/3 of all the kids, 2/3 of all the kids in the town are going to have height between 3.5 feet and 4 feet, or 4.5 feet rather. It gets even more interesting. It gets even more interesting. If we go one more standard deviation, we capture another 14% on this side, we capture another 14% on this side. So now 34 plus 14 is 48, which means this part, the leftover part, is only 2%. 2% in this tail, 2% in this tail. So we can go further. 2 standard deviation, mean plus or minus 2 standard deviation captures approximately 95% of all the population. In other words, in our example where we said that we took the measurement of the heights of the kids, our 10-year-old kids, and they were 4 feet high, the mean was 4 feet and the standard deviation was 6 inches, well, 2 standard deviation will be 1 foot, which means 95% of all the kids, assuming that distribution is normal, 95% of all the kids in this survey will fall between the height of 3 feet and 5 feet, because 4 feet plus 6 inches plus 6 inches, that represents 2 standard deviation. As you can see, 1 standard deviation, another standard deviation, which gives you a foot here because the standard deviation was 6 inches. So if the mean is 4 feet, 2 standard deviation would be 3 feet to the left, and 2 standard deviation to the right would be 5 feet. So 95% of all the kids will have a height between 3 and 5 feet. That's the idea. Let's do the problem here. That's too much talking here. Oh, I shouldn't have erased. Well, we have to erase it. We need room. But this is very basic stuff about normal distribution that they expect you to understand. The GRE people expect you to understand. A couple of years ago, you didn't have to worry about it because this concept of normal distribution did not appear on the exam. But nowadays, it does. So let's do our work. So here we have a normal distribution. We have 3,000 observations apparently. We have a normal distribution. The mean is 65 inches. And the question simply is, how many will fall between 65 and 75 if we are told that the standard deviation is 5? So here we go. Problem number 16. We have a population of 3,000. We are told that the mean is 65 inches. The standard deviation, we are told, is 5 inches. Whether it is 5 inches or 5 centimeters or 5 meters, it doesn't really matter. The unit is of no interest to us. Question simply is, how many will fall between 65 and 75? Well, let's take a look at it. Between 65 and 75, the mean is 75. This is the mean. So this is 65, mean plus 1 standard deviation, because the standard deviation is 5, mean plus 1 standard deviation will be 70. This is 65 plus 5. That's only 70. We're looking for from 65 to 75. So we got to go one more standard deviation. 65 plus 2 times 5. So the area that we are interested in is this area right here. This area right here. That's the area that we're interested in, which is the mean plus the 2 standard deviations. So how many will fall between 65 and 75? That's the question. And as we just saw, between 65 and 75 represents, I don't know how to spell represents area under the curve, represents the area under the curve. From mean to mean plus 2 standard deviation. From mean, from here to mean plus 2 standard deviation right here. And which of course we know is, this part is 34%, this part is 34%, This part is 14%. So we're looking for 34% plus 14%. We're looking at 48%. And that's how simple it is. That's how simple it is. So now the question boils down to, what is 48% of 3000? That's it, because total number of observations is 3000. So now the question boils down to, what is 48% of 3000? That's all they're looking for. What is 48% of 3000? Because 34% of all the observations fall between 65 and 70. How do we know that? Because 5 is the standard deviation, 65 is the mean. So mean plus 1 standard deviation captures 35% of all the observations if it is normally distributed, which in this case it is. Mean plus 2 standard deviation will take us all the way up to 34 plus 14. That's 48% of the observation. We just have to figure out 48% of 3000. Let's do it here. So what is 48% of 3000? What means X? Is means equals 48%. 48% means over 100. Of means times 3000. And if you do not know what I just did here, I don't have the day number in front of me, and I don't want to run to this other room again. Besides, it's not something handy. I can just look up, I could get it in 10 seconds, obviously. But if you do not know what I just did here, just type in my name. Just type in my name and put in GRE percentage problem, something to that effect, and you will see a whole bunch of percentage problem, which will give you plenty of practice as to how to convert an equation into an algebraic, how to convert a word problem into an algebraic equation. What you replace it with unknown, that's your X. Is means equals, 48% means over 100, of means times 3000. We just have to solve for X. So these two zeros cancel out with these two zeros, and it's basically 48 times 30. Let's do it here. 48 times 3, 8 3 is 24, carry 2, 12 plus 2 is 14. So, and because we don't have 3, we have 30 here. We have 30, so 48 times 30, we just stick a 0 here. The answer is 1440. How many observations out of the 3000 observations will fall between 65 and 75? The answer is about 48% of the observations, which turns out to be 1440. Let's do part B, shall we? Let's do part B. That's it, we're done with this thing. Part B says, what are the odds that, Part B says, if an adult penguin is chosen at random from the population, approximately what's the probability the penguin will all know? Okay, what are the odds that, one picked at random, one, whatever it is here, whether we're dealing with a bunch of penguins, a bunch of rats, a bunch of people, it doesn't matter. Whatever it is, if you were to pick one subject at random, that's how we say it. If you were to pick one subject at random, what are the odds that one picked at random will be of height less than 60? Well, less than 60, let's find out. Less than 60, this is how we write it. Probability that height is going to be less than 60, that's how we write it. And let's see where it shows up in the graph. Here is 60. This is m minus d, which is our m mean is 65, so 65 minus 5, that's our 60. So we're looking for something below that. Something below that is this part right here. We know that this part, we know this area is 14% of the population, and this remaining part is 2%. So it's 14 plus 2, 16%. That's what it is. The odds that one penguin picked at random will have the height of less than 60 is simply 14% plus 2%. 14% 14% plus 2%, which is 16%. But that's not the end of it. You have to be very careful in this new format of the exam, the revised GRE. You have to be very careful with it, because here nowadays in the new exam they tell you to round it to some weirdest thing. They will tell you to round it to the nearest fifth, or round it to the nearest 100, or round it to the nearest this, nearest that. Here they are looking for, answer nearest to 0.05, which is very weird, nearest to 0.05. Therefore 0.16, which is what this is 0.16 in decimal, 0.16 rounded to nearest multiple of 0.05 is 0.15. Therefore, the correct answer that is accepted here as the correct answer is 0.15, not 0.16, because they ask you to round it to nearest 0.05, and the nearest multiple of 0.05 would be 0.15, because the next one would be the 0.2, because you have to go in the multiple of 5s. So if you did all the work, and if you at the end had it been open-ended question, had this thing appeared as an open-ended question, or even multiple choice question, either case, even if this had been a multiple choice questions, obviously they will give you 0.16 and 0.15, both of them as the answer choice, and your job is to be careful with the wording. The correct answer choice that is considered correct here is 0.15, because of the way they have phrased the question. Nearest 0.05 they are looking for, and the nearest 0.05 to 0.16 is 0.15. That's it, we're done with it, finally. Took me a long time. That's because I wasn't planning to explain the basic things about the normal distribution, but then I kept on going. Anyway. But there's more stuff, as I said, on day number 36. If you want to learn a little bit more, if you want to learn in a little bit more detail about the normal distribution, watch day 36 and you will get something out of it. Okay? Just type in revised GRE math, day 36. Alright? Bye now.